Hello guys, just we'll go with your deadlock problem. Okay, first example. Okay, just the question will be like this. Consider a system with 5 processes P0 to P4, P0, P1, P2, P3, P4 and 3 resources types A, B, C. A, B, C. 3 different types of resource are there. And they said that resource type A has how many instances here? 10 instances in your system. Total number of resources available of resource type A is how much? 10. B is having how many? 5. Maximum resources available in your system. B is how much here? 5. And C is how much here? 7. At time P0, they have said that following snapshot is been taken. Justify your answer whether the system is in safe state or not. You need to write the safe sequence. Okay. So here, according to your banker's algorithm, they have given allocation, maximum, available, but I need to calculate what? Your need. They have given allocation, maximum and available. I need to calculate your need. Okay. I said that in your deadlock avoidance, what happens is whenever a process enters the system, every process has to specify what is the maximum number of instances of each resource type it needs. Here, P0 will say, I need maximum how many instances here? 7 instances. I need B. How many? 5 instances. I need C. How many instances here? 3. But this should not exceed what? The total number of instances available in your system. It should not exceed what here? The total number of instances available in your system. Sometimes what happens is they may not give available. What do you mean by available? After allocating the resources to every process, still how many resources are available in your system? That's what it says. But what do you mean by max? Every process has to specify what is the maximum instance of each resource type it needs. Allocation, how many instances of each resource type is being currently allocated. So according to this P0, it says that maximum it needs how many instances of resource type A? 7. But currently allocated is how much here? 0. And maximum how many instances of resource type B? It needs 5. How many maximum instances type of resource type C? It needs 3. But currently allocated B is how much? Only 1. C is how much here? 0. Hope you are getting. Still, how many resources it needs to complete its task? Okay, that I can calculate by need. Need is nothing but what you can say is max minus allocation. And one more thing, what happens is sometimes available may not be given. At that time, what happens is you need to add all your allocation. So I'll add 3, 4, 5, 6, 7. A, total number of resources allocated is how much here? 7. B, total number of resources allocated to your process of resource type B is how much here? 2. Total number of resource type C allocated is what? 2, 3, 4, 5. So what I can do is I can subtract this with what? The total resource available in your system. 3, 7, 2, 5. So what I'll get? 10 minus 7 is 3. 5 minus 2 is 3. 7 minus 5 is 2. Okay. Obviously they'll give this one. If they're not given, this is the way to calculate. Hope you are clear. Okay. So next, according to your banker's algorithm, there are 4 variables: allocation, maximum, available. I need to calculate need. Means what is by need is nothing but maximum it has to specify, and system will allocate current resources to your process. Still how much it need? Max minus allocation. So 7 minus 0. You should not say 753 minus 010. That is wrong. It is separate resources. A is separate resource, B is separate resource, 3 is separate resource. So 7 minus 0. Still P0 need how many more resources to complete the task? It needs 7. So B, 5 minus 1 is still how many resource type of resource type B it needs? Still 4 instances it needs. Next, C, maximum it needs 3 but currently allocated with what? 0. So 3 minus 0, still it needs what here? 3 instances of resource type C, P0. Next P1, maximum it needs A is of 3, currently allocated is 2. So still how much it needs? So 3 minus 2 is 1. So 2 minus 0 is 2. 2 minus 0 is 2. Okay. Next P2. Maximum of A it needs 9 but currently allocated with what? 3. Still how much it needs? 9 minus 3 is 6. B it needs 0 but currently not allocated, so 0 itself. So maximum it needs 2, currently allocated is also 2. So no more required. So 2 minus 2 is how much? 0. Okay. Next here. Same way. 2 minus 2 is 0, 2 minus 1 is 1, 2 minus 1 is 1. For your P4 process, 4 minus 0 is 4, 3 minus 0 is 3, 3 minus 2 is what? 1. So this is what I get based on your Banker's algorithm. Hope you are clear with this. Now I need to check what? Justify your answer whether the system is in safe state or not. To check what is the sequence of execution, I need to go with what? Safety algorithm. So I can go with the safety algorithm. Here it is there. So first case, what happens? I'll just assign available to a variable called as work. So what is your available? 332. Now work has been assigned to what here? Available. That is what? Available right here. That is work is what? 332. Next what it says? Finish of I. Means I is nothing but your processes. First P0 is what I'll do. I'll just make it as false. I'll check. Find I such that finish of P0 equal to false is. Then what I'll do is, they said that need of I is nothing but now it is P0. So need of P0 is less than or equal to work. I check need. Still how many resource P0 need here? A 7, B 4, C is how much? 3. Is less than or equal to work is how much? A is still 3 available, B is 3 is available, C only 2 is available. I need to check. 7 is less than or equal to 3? False. Process P0 need 7 instances of resource type A, but only available is how much? Only 3. So this becomes what? False. If once become false, you can't execute at all. So your P0 can't execute first. Okay. Again, what happens? If this is the case, again I'll repeat. I'll go for which one here? P1. Okay. I is equal to becomes what here? P1. So P1, need of P1 is less than equal to work. I'll check. Okay. So need of P1 is what? That is 1, 2, 2. Need of P1 is what here? 1, 2. Once is check. A, it need how many instances here? 1 instance is less than or equal to 3? Yeah, true. Means A, it need 1 instance, but available is how much? Still 3 resources are available. Okay, true it is. 2 is less than or equal to 3? Yeah, true. B, okay, it need P1 need 2 instance but 3 available. True. C, it need 2. What is available? 2. So 2 is less than or equal to 2. True it is. When that is the case, what happens? P1 will execute. P1 will execute. Then what happens is work is equal to work plus allocation of which one? Allocation of P1. Means once it executed, what does it do? It releases the resources. Means whatever it is been currently allocated, it is going to release the resources. What is your work? What is your available? 332 plus allocation of P1. How much it is? 200. Once it is executed, it releases. So then what happens? 3 plus 2 is 5. 3 plus 0 is 3. 2 plus 0 is what? So next, work will become what? It becomes 532. It becomes what here? 532. So I need to write the safe sequence. This is what the marks carries. Okay. Which is the first process to execute is P1. Okay. Still P0 not executed. Okay. Hope you are getting with this. Okay. So see here. Finish of I equal to true. Means what I will do is finish of P1. That is true. Okay. So next one, that is the case, go to step 2. Again, you will go for what? Second process. Okay. I is what? 2. Now what you will do is, need of P2 is less than equal to 1. Need of P2 is how much here? 600 is less than work. New work is how much? 532. 6 is less than equal to 5. So P2 need A. How many instances here? 6 instances. But total available in the system is only how much? 5. So that is false. So what happens? Your P2 also can't execute. P2 also can't execute. Then what I'll do is, I'll go for what? P3 process. I'll go for what? P3 process. Now, need of P3. How much here? 0, 1, 1 is less than work is how much? 532. Okay, P3, maximum how many instance A it need? Already allocated 0 it is. 0 less than or equal to 5, true. B 1, but available is 3. 1 less than or equal to 3, true. 1 less than or equal to 2, it is true. So then what happens is the next process to execute is P3. Once P3 executes, what happens? It's going to release the resources. So work is how much? 532 plus allocation of which process? P3 process. Allocation of P3. How much it was allocated? It's going to release the resources. So what is the new work? 5 plus 2 is 7. 3 plus 1 is 4. 2 plus 1 is how much here? 3. So new availability is what here? 743. Hope you have read P3 executed. So next I'll check for what? P4 process. P4 process. Yeah, need of P4 is how much here? 4, 3, 1 is less than equal to new work is how much? 7, 4, 3. Yeah, 4 is less than equal to 7, true. 3 is less than equal to 4, true. 1 less than or equal to 3, it is true. Then work is equal to work plus allocation of which one? P4. Means next process that can execute is which one here? Your P4 process can execute. P4 process can execute. What was your work? 7, 4, 3 plus allocation of P4. You can just check it out. How much it is? 0, 0, 2. So the new work will become what? 7, 4, 5. New work will become 7, 4, 5. Hope you are clear. Now again I need to check which all process not completed. P2, P0. I need to go in reverse order. So P2 I'll check first. So next I'll check with what? P2. Need of P2. Need of P2. Need of P2 is how much here? Here it is. How much it is? 600 is less than or equal to work is how much? 745. 6 is less than equal to 7, true. 0 less than equal to 4, true. 0 less than equal to 5, true. Means now P2 can execute after P1, P3, P4 is going to release the resources. So next process to execute is which one here? P2 process. Once it executes, what does it do? It releases the resources. What was your work? 745. Allocation of which one? P4 process. Allocation of which one here? P2 process. So how much it is? 302. Right. So 7 plus 3 is how much? 10. 4 plus 0 is 4. 5 plus 2 is this 7. Hope you are getting with this. So this is your new work. That is 10, 4 and this 7. So 10, 4, 7. Okay. Even P2 completed. Only process left is which one here? P0. I'll check with your P0. Need of P0 is how much here? Need of P0 here, it is 7, 4, 3 is less than equal to 1. How much here? 10, 4, 7. 7 is less than equal to 10, true. 4 is less than equal to 4, true. 3 is less than equal to 7, true. So P0 can execute after what? Your P1, P3, P4, P2 has been released the resources. So next process to execute is which one here? P0. Hope you are clear. After allocating, what happens? It releases the resources. What was your work? 10, 4, 7 plus allocation of which one here? P0 is how much? Allocation of P0 is what? 0, 1, 0. So it becomes 10, 4 plus 1 is 5, 7 plus 0 is 7. So 10, 5, 7. See here. Now after releasing all the resources, whatever the total resource that was available, A 10, B is 5, C is what here? 7. Hope you are getting with this. See now, I need to write the sequence. This is where the marks carries. So after writing this, so this is the sequence in which the particular process can execute. Hence, the system is in safe state. So this is the safe sequence in which the process can execute. Hence, what you can say, the system is in safe state. There is no deadlock. in the system. There is no deadlock in the system. Hope you understood with this. We have one more algorithm called as resource request algorithm that we'll discuss for the same problem.